All right, guys. So title your notes, section 10.7, day 3. And we are going to test polar equations for symmetry. Okay, so we've talked about symmetry. We've talked about polar axis symmetry, right? The polar axis is the horizontal axis. So here's an example of a graph that has polar axis symmetry. We've talked about symmetry with respect to the vertical axis. So we call that symmetry with the line with respect to the line theta equals pi over 2. That's the line theta equals pi over 2. Okay, that's your vertical axis symmetry. And we've talked about symmetry with respect to the pole. The pole is the origin. Okay, so these are the 3 types of symmetry. So let's talk about what's special about these graphs and then how to prove the types of symmetry. So with polar axis symmetry, if you have a point with a certain r value and a certain theta value, you're going to have that same point reflected over the polar axis with the same r value, but what's different? That's right, the angle is negative, so negative theta. That's important. Okay, write it down. If you have vertical axis symmetry, if you have a point with a certain r value and a certain theta value, then you're going to have that same point flipped over the vertical axis. Notice how you might say that there's a difference, right? The angles are different. Is it always 180 minus theta? Maybe, maybe not. What else is true? Well, if you have a point, or what would be another way of writing the second point over here? It would be the same as flipping theta, right? Negative theta, and then making the r value what? How do I get it to the second quadrant? Negative. Very good. So that's what's important. Oops. So write that down. If you have point theta r or r theta, you're going to have the point negative r negative theta. And then finally for the pole, for pole symmetry, if you have a point r theta, you're going to have that same theta value, but how do I get to the other side? With negative r. So write those down. Okay, so how to prove these? So, you can't just say, oh, but look, I graphed it. You can see it. That's a proof. Not quite. We're going to have to do a few things. We're going to have to do 3 tests. The first test will test for polar axis symmetry. The second test will test for symmetry with respect to the line theta equals pi over 2. And the third test will test for symmetry with respect to the pole. So let's look at these tests. So test number 1. If I had you test for symmetry with respect to the polar axis, you need to plug in negative theta for theta. And if you get back the same equation, that means that you're going to get back the same graph, then you're going to have symmetry with respect to the polar axis. Okay, so when you do this for the whole graph, you're basically checking that for every single point, if you have r theta, you're going to have r negative theta as a value. So that's the first test. So symmetry with respect to the polar axis. And we'll do an example. The second test, so feel free to pause, write this down, and then play again. The second test is symmetry with respect to the line theta equals pi over 2. So if you have a point r theta, you're going to have a point negative theta, negative r. So that means if you plug in or substitute, I guess the appropriate word is substitute. If you substitute, what are we going to substitute? Negative theta for theta and negative r for r, and you simplify your equation and you get the same equation, then you're going to have symmetry with respect to the line theta equals pi over 2. Okay, vertical. Okay, 2 tests. I want you guys to make flashcards out of these. Okay, you're going to go home and, oh, you are home. Sorry. You're going to make a flashcard where in the front you're going to have the test for, whatever test you're testing for, and then the back you're going to put what you're supposed to do plus an example. And I have examples, don't worry. Okay, I'm just going over the test first. The third test, okay, we're going to have the test for symmetry with respect to origin. So again, feel free to pause, write down, and then come back. All right, so we're going to replace r with negative r, because if you have a point here, r theta, you need to have a point somewhere over here at the same angle, negative r. Okay. Or if you have a point over here, let's say r theta, you need to have a point over here. So it's not symmetry with respect to the line y equals x. Not quite. It's more like, if you're going to have a point here, it's going to come back this way. Okay. Kind of like when we had tangent. Remember all the odds. Okay, are going to it's similar to that. All right. So r theta, negative r, same theta. So you replace negative r with r. You simplify, and if you get the same equation, you have symmetry with respect to the pole. Okay, so this is the third test. So all these tests, I want you to make some flashcards, okay? I'm going to let you use flashcards on the test because I don't have much of a choice here. So might as well practice. Okay, so these are the tests. We're going to try some examples next.